Good afternoon, class. Here's Module 1, Chapter 2, Equations and Inequalities. All right, we want to answer the following questions. Find the distance between the 2 points, -5, -6, and 4, 2. Also, we want to find the coordinates of the midpoint of the line segment that joins the 2 given points. So let's remind everybody what each one is. Starting with the distance formula. If we are interested in calculating the distance between 2 points, one has coordinates x sub 1, y sub 1, one has coordinates x sub 2, y sub 2. Using Pythagorean theorem, a squared plus b squared equals c squared. If you take this to be a, this one to be b, and this is the c, we can get to the answer, which means square this side, put it under the radical, and it gives you this side. Now, what is this side? The change in y sub 2 over y sub 1. What is this side? The change in x sub 2 minus x sub 1. And that's why it's in the absolute value, because we're talking about the distance. And which point is the first point makes no difference, because when we square them, we get to the same answer. So having said that, we are going to put the 2 into this formula. As I mentioned, it doesn't matter which one is our first point, which one is our second point. So if this is the first point, then this is x sub 1, y sub 1, and this is x sub 2, y sub 2. We plug it into the formula of the distance. So 4 minus -5 gives us 4 plus 5 squared. That's the first one. 2 minus -6, that means 2 plus 6 squared. And so we get, this is 9, this is 8, square the 9, 81, square the 8, 64. Put them together, 145. Now, this is the exact answer, everybody. So if somebody says, okay, what is the exact answer? Here's your answer. And this is an approximation. And how many decimals? Whatever they ask you. Normally, you carry a lot of decimals unless they tell you how many. Then you stick with that. The next one, we want to find the midpoint, the coordinates of the midpoint of the line segment that joins the 2 pairs. So if one of them has coordinates x sub 1, y sub 1, one of them has the coordinates x sub 2, y sub 2, the midpoint is x sub 1 plus x sub 2 over 2, and y1 plus y sub 2 over 2, and it really follows similar figures. And if you draw a parallel line here, line segment to x-axis, draw a parallel line here to the y-axis, this makes a 90-degree angle. And if you drop a perpendicular to the x-axis, let me use a different color here, from here or parallel to the y-axis, it's a 90-degree angle. Then these 2 triangles are identical, they are called congruent, because we know this distance is equal to this distance. When you drop a perpendicular, it cuts this in half. And so this is equal to that by the similar figures. They end up being equal. These two are equal. And therefore, if this is midway, to find the x coordinates for the midway here, by the way, this is x sub 1, this is x sub to all of them, this one, this point, and this point. Okay, so x sub 1, x sub 2. So x sub 1 and x sub 2. So we get the midpoint using this formula. And so add them up. We are going to add up their x coordinates and their y coordinates and divide by 2. So minus 5 and 4 is negative 1/2. Minus 6 and 2 is minus 4 halves, which is negative 2. Therefore, we say that in part A, the answer was square root of 145 precisely. This is an approximation. And the answer to part B, the midpoint has coordinates negative 1/2 and negative 2. Could somebody read the question for us, please?
I'll do it.
Sure, thanks, Stacy.
A man drove 10 miles directly east from his home, made a left turn at an intersection, and then traveled 5 miles north to his place of work. If a road was made directly from his home to his place of work, what would its distance be to the nearest tenth of a mile? If the road was made in the previous exercise, how much shorter would the man's one-way trip be every day? Sorry.
Excellent. Thanks. Class, anytime we have a word problem, it helps to do the drawing to see what's happening, if that's possible, or in any event, we have to translate this mathematically so we can follow that. So we're going to go this way, eastward, 10 miles. Made a left, traveled 5 miles north. So we are going this way 10 miles, up north, 5 miles. And it may or may not be to scale, it doesn't matter. So that's this setting. If a road was made directly from his home to his place of work, what would its distance be to the nearest tenth? That means from here to here. That's what we are looking for. We are interested in this distance, everybody. So we use Pythagorean theorem. A squared plus B squared equals C squared. So we plug in. A is 10, B is 5, C is missing. So c squared is 125. We take a root, and this is exact. And this is an approximation. Now to the nearest tenth of a mile. So that means 11 point, look at 1, next to it is 8. So right. .2 miles. This is how we do the right rounding accordingly. Part B. If the road was made in the previous exercise, if we had this, how much shorter would the man's one-way trip be every day? Well, we're going to go this way 10 miles, this way 15 miles. But instead of going 15 miles, we're going to go this much. So 15 minus this number. I'm going to write this number, and I'm going to do the rounding with this. So 15. So 10 plus 5 minus square root of 125. This is the exact answer, everybody. And you can carry many, many decimals. However, going back to what they said, 15 minus 11.2. Let me just write it down. So this is 15 minus 11.2. And it will save us this much, about 3.8 miles. Questions? I'm going to move on. We want to solve this equation. And this is a rational equation. The best course of action to solve a rational equation is to factor every denominator and then multiply by LCD, the least common denominator, to get rid of all fractions, and of course exclude whatever makes each fraction. Therefore, when we look at the first one, this is a prime polynomial, so is this one. All you have to do, factor x squared minus 2x minus 3. So we want two numbers. The product is -3 and the sum is -2. We get +1 and -3. I'm assuming nobody has any problem with factoring, something we learned in elementary algebra. And so 5 over x plus 1 remains, 1 over x minus 3 remains, minus 6 remains. The denominator of the last fraction changes to x plus 1 times x minus 3, which means now two things. Number one, you look at each fraction and say, what is it that you cannot have? If you look at this one, x can't be -1. If you look at this one, x can't be +3. This happened to give you the same result. Now, why is it important that you write this? X can't be -1, X can't be 3, which in essence is one way to write the domain. Why is it important? Because when we finish the job, for the sake of argument, if we end up with a couple of solutions, one of them is one of those, we say it's an extraneous solution, which means in the process we found it, but doesn't work with the original equation. Therefore, we make this available, and at the end we check it. Now, the fastest way is to multiply by LCD. What is the LCD? The product of these two or these two. Now what happens? What does this mean? It means we're going to multiply each fraction by this. So if you multiply this fraction by this, x plus 1 goes away, you get 5 times x minus 3. The second fraction, x minus 3 goes away, plus 1, whatever this is, plus 1 times x plus 1. And the right side, everything goes away, and what remains is the numerator only. So 5 times x minus 3, 1 times x plus 1 equals -6. So I hope you see how fast and how easy you can solve this. Okay? And so what we have now is this simple linear equation we are going to solve, everybody. Five x minus 15, I'm distributing, plus x plus 1. Now we can combine these two into 6x minus 15, and 1 is negative 14, moves to the right, becomes positive 14, this is what we get. And we simplify it to 4/3. 4/3. So that's how you solve a rational equation. Then what do? You say, okay, let me check. When you check here, that means it works. You can always plug it back. By the way, you got to plug it back into original equation to check. But assuming you haven't made a mistake here, what you have to check is what you excluding. You're excluding -1, you're excluding number 3. So again, for the sake of argument, let's say that two answers, one of them was 3, you would say 3 is an unacceptable answer just because of what you wrote here in the beginning. Okay. All right. Let's discuss lines, slopes, and everything else, things we have seen before. Let's go over the synopsis of that for everybody. So we have a line, L. If we have a couple of pairs, x sub 1, y sub 1, x sub 2, y sub 2, the slope is defined as rise which is y sub 2 minus y sub 1, over run, which is x sub 2 minus x sub 1. This is by definition. So we call this what? There are different ways of writing it. M is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, delta y over delta x, rise over run. They all mean the same thing. This is known as the average rate of change of y with respect to x. Average rate of change of y with respect to x. When we look at this, we notice this is the x, this is the y. This is a line with a positive slope. This is the line with the negative slope. Horizontal line has a slope which is 0. Vertical line has a slope which is undefined. The concept of a positive slope means when we go from left to right, obviously everybody knows x increases. No question about that. But in this case, in this case of it, this line, as x increases, so does y. This is the meaning of positive slope. Maybe I write it on the left, so I need this space. So positive slope means this. If you look at this line, negative slope, when x gets larger, y gets smaller. When you're looking at a horizontal line, as you go from one point to the other, the x gets larger and larger on the right, but the y doesn't change. And in the case of a vertical line, it's undefined. So what we want to add the equation of a HL or horizontal line, y equals b, slope equal to 0, the y-intercept at 0, b. So if you look at this horizontal line as the equation y equals b, where this point in general is 0, comma b. In this case, whatever you read it from the graph, but that is the point of this question. And in the case of a VL, short for vertical line, the slope is undefined because if you calculate the rise over run, the denominator will be 0. The vertical line has an equation of x equals a, and the x-intercept is located at a0 in general. So this point has coordinates a comma 0 in general. Parallel lines versus perpendicular lines. And even before we go there, let's look at all the forms of a line. Standard form ax plus by equals c. And I'm going to remind you what this really means is that x and y are on the same side. In some text, they even put the constant on the same side. In some texts, even c is on the same side. Slope intercept form, y equals mx plus b. If you solve for y, what you end up with is a slope intercept form, which means m is the slope, 0, comma b. As a pair, if they say what is the y-intercept, if they ask you for b, just you write b, but if they want a pair, 0, comma b. We also have a point slope. Y minus y1 equals m times x minus x of 1. Two lines are parallel if they have equal slopes, different y-intercepts. Two lines are considered parallel if they have equal slopes, but their y-intercepts must be different, otherwise the same line. Two lines are considered to be perpendicular, meaning they make a 90-degree angle at the point of intersection, if their slopes are negative reciprocal of each other. Either you can write m sub 2 is minus 1 over m sub 1, or you can say their product is negative 1. In other words, if I were to draw a line, let's pick a proper color. If I draw a line here, and I'll call this L sub 2, then L sub 2 and L are parallel. And if I call this L sub 3, making a 90-degree, here L sub 3 is perpendicular to both lines L and L sub 2. So this line is perpendicular to these two lines, L and L sub 2. So L and L sub 2 are parallel. L sub 3 is perpendicular to both lines. So this was the synopsis of what we know about lines, their slope, and more importantly, the interpretation that becomes very important in algebra ultimately, which is the average rate of change of y with respect to x, and we need to understand that concept. All right, we want to answer the questions. In this case, we want to graph the following lines in a rectangular coordinate system and clearly show the intercept on the graph. As you can see, x equals negative 2 and y equals 3. X equals negative 2. It is a vertical line, okay? So it goes this way. That means it's parallel to the y-axis, or you might even say perpendicular to the x-axis. So because this is negative 2, you look for the x-intercept negative 2 comma 0, which is this point. You put it there, and then you drop a perpendicular. That's all there is to it. In the case of a vertical line, this point as the coordinates negative 2, 0. If you pick any point, you can pick up any point you want. And the x coordinate, for example, right here, let me just, right here. See, I already know what is the x coordinate. As far as the y coordinate is concerned, it's 5. If I pick this one, again, the same x coordinate. What about the y? I just read it from the graph. So that's the beauty of the vertical lines. Basically, if you have the x-intercept, it makes it easy to graph. On the other hand, if you look at y equals 3, which is a horizontal line, all you have to do look for the y-intercept, and the y-intercept has coordinates 0, 3, right here, right here. Excuse me. And then you draw a line parallel to the x-axis or perpendicular to the y-axis. So if I pick a point like here, for example, for example, here, well, I know the y coordinate, but what is the x coordinate? I just do the reading. That's it. So it's very easy to draw a horizontal line as well. All right, we want to find the equation of a line containing this pair. In order to find the equation of a line, we normally have to go through the process of finding it. But in this case, it's very straightforward. If the two pairs have the same x coordinate, you do not have to look too far. The answer is simply x equals 4. So again, both pairs have the same x coordinate. That is the equation, x equals that. It is a VL, a vertical line with the equation x equals 4. We want to find the equation of a line containing those two pairs. Similar situation happens. We have the same y coordinate. Again, if the y coordinate repeats, then the equation is y equals that. It's a horizontal line with that equation. It's pretty straightforward. So vertical lines versus horizontal lines. All right, we want to find the equation of the line in slope-intercept form that contains or passes through these two pairs, -3, 10, and 5, -6. And we want to find the intercepts and we want to graph it. By the way, as far as graphing is concerned, you can use those two pairs and graph. But the difference is if you have the intercepts, it's a little bit more precise normally. So the first step is to find the slope. And I'm going to remind you of some of the formulas we had before. The slope, rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is the formula we're going to use. And we're going to use it on those two pairs. Now the question is, which one is the first point? Which one is the second point? Makes no difference. Okay? You can put them in any order. If you're consistent, you come up with the correct answer. So if we go just the way it's given, this is the first point, this is the second point. Y sub 2 minus y sub 1 means -6, -10, that's the numerator. And the denominator, x sub 2 minus x sub 1 means 5 minus -3. So I'm going to show you, in case you write it the other way around, if you take this one to be the second and this one to be the first point, then you would put 10 minus -6 over 5 minus -3. Let's see what happens. I want to make sure you understand that it works both ways. So this one is obviously -16. This is +3. and that makes it 8. So negative 16 over 8 gives us negative 2. I'm so sorry, this one, I meant minus 3 minus 5, which makes it 16 over minus 8, which makes it negative 2. So we got to be consistent. Now, we want to find the equation of a line, and we are going to go with the point slope. Y minus y1 equals m times x minus x sub 1. And again, it doesn't matter which pair we choose. So let's say we choose the first one. Y minus 10 equals m negative 2 x minus negative 3, which means x plus 3. We're going to use this formula. Replace the y sub 1 with 10, m with negative 2, minus negative 3 or plus 3. We're going to distribute. So we get y minus 10 equals minus 2x minus 6. We move the negative 10 becomes positive 10. With negative 6, we get minus 2x plus 4. And so, clearly, the y-intercept is 4, meaning 0, 4. So we don't have to look for it. When we put it in slope-intercept form, we already have a one pair 0, 4. Now, what about the x-intercept? We set y equal to 0. If you set this one equal to 0, I hope you see that x becomes 2, and therefore those are the intercepts. So this is the y-intercept. This is the x-intercept. So let's plug in. We have 0, 4, we go 4 up here. 2, 0, we go 2 to the right. So those are the two pairs. Connect them. And also let's put the two pairs. One of them is 5, negative 6. One of them is minus 3, 10. There wasn't enough room for that, but I just wanted to emphasize you can always use the original pairs, but when you find the intercepts, it makes it more precise. All right, let's move on. We want to find the equation of a line that is perpendicular to 3y equals x minus 4, to this line, and passes through this pair, minus 2, 1. Now, before we go there, let me just explain something about the previous page, by the way. Class, remember we use this pair. I highly recommend, if you use this pair, you get to the same answer. I highly recommend you check it with the pair that you haven't used. We didn't use this pair to come up with the equation. So go to this equation, replace the x with 5. Minus 2 times 5 is minus 10 plus 4. Do we get minus 6? The answer is yes. That's how you check it. Always check your work if you can. So we want to find the equation of a line that is perpendicular to 3y equals x minus 4 and passes through the point minus 2 comma 1. We want to find the intercepts and graph. As always, the reason we want to find the intercepts because it makes the graph look better, okay? So let's get started. First and foremost, we need to put this in slope-intercept form in order to find its slope. So you have to solve for y. You're going to divide by 3. You're going to divide both sides by 3. I'm going to divide this one by 3, this one by 3, this one by 3. And when you do that, the slope becomes 1/3. And the reason I'm going to call it m sub 1, I'm referring to the first line. This line, the slope is 1/3. You can call it just m. So if I wanted a line parallel to it, the slope would be the same. But I want a line that is perpendicular to it. Therefore, it's the negative reciprocal of that. So the reciprocal is 3, negate that is negative 3. So flip this over and negate that. And now, let's come up with the equation of a line that is perpendicular to that using this formula, y minus y1 equals m times x minus x of 1. So that means y minus 1 equals m3 x minus negative 2. X minus negative 2 means x plus 2. Let's distribute. Let's move the negative 1, put them together. So y equals minus 3x minus 5 is the equation of a line that is perpendicular to this line and contains this point or passes through that point. So what do we do? The next thing is to find the intercepts and graph. Well, first let's find the intercepts for this guy and graph this one. And then we find the intercept for this one and graph it. For this one, we already know one of the intercepts, 0 minus 4/3. So we already know the y-intercept. So what is the x-intercept? You want to find the x-intercept. You can use that formula or you use this formula. It may be easier that way because if you want the x-intercept, you set y equal to 0. And therefore 3 times y is 0 times x minus 4. X becomes 4. And so this is the x-intercept. And this is the y-intercept. Very simple. So 0 minus 4/3. Minus 4/3 means minus 4/3 means minus 1 and 1/3. So between negative 1 and negative 2, 1/3 of the way. 4 to the right, 0, and that's the line. So that's the original line, the given line. What is the line perpendicular to that? Well, this is the line. We already have the y-intercept is located at 0, -5. So the y-intercept is given as 0, -5. What is the x-intercept? You set y equal to 0. If you set y equal to 0, x is -5/3. So we have the y-intercept 0, -5. So we go 5 units down. That would be the y-intercept. -5/3, 0. That means -1 and 2/3. So this is -1 and 2/3 is cut this into 3 pieces and the second part. So those are the two pairs. Put them together. And what is this pair? This line is supposed to contain -2, 1, and it does. So that's how you graph the setting. The setting includes both lines, all intercepts. That means intercepts for the first line, for the second line, and the pair that it's supposed to contain. It's pretty straightforward, everybody. And this is -2, 1. -2, 1. All right, we're going to look at this example, which is a word problem. Can I ask someone to be nice to read it for the whole class, please? Could somebody be kind enough to us?
I could read it.
Please.
A retired woman has $50,000 to invest, but needs to make $6,000 a year from the interest to meet certain living expenses. One bond investment pays 15% annual interest. The rest of it she wants to put in a CD that pays 7%. A, if we let X be the amount the woman invested in the 15% bond, how much will she be able to invest in the CD? B, set up and solve the equation for how much the woman should invest in each option to sustain a 6,000 annual return.
Excellent. Thank you so much. So anytime we do word problems, it's important to understand what's given. And this is about investment. And in essence, it's what we call a mixture problem. So first, you have to set up the following table. You're going to say, okay, we're going to have the investment. One of them is at 15%. One of them is at 7%. This is the total. This is the amount that we're going to put for the 15%. This is the amount at 7%. This is the total amount. I equals PRT. I hope everybody remembers. Simple interest equals P the principal times R the rate times T the time in years. I equals PRT, principal, rate, time. So, again, let me just write this. This is a class of problem. Normally, when we say mixture problem, we may think of problems when we mix up two solutions, which is a mixture problem. This, in essence, does the same thing. Why is this called a mixture problem? I'll go over the reasoning for that in a moment, but for now, let's plug in what we have. So how much do we have? We have $50,000 to invest total. So the total amount is $50,000. So it goes here. So how much do we have? 50,000, that's the total. We need to make how much? 6,000. That means the total interest we need to make is this much, 6,000. So we have 50,000. We need to make $6,000 worth of interest. One bond pays 15% and the rest 7%. And by the way, one might say, why not put all of them in 15%? There are some, issues and taxation issues and other issues that may not let you do that. And so let X be the amount the woman invests in the 15%. So in the 15%, we put how much? X amount. If they didn't tell us, you can use a different variable or just put the X here and figure out what's going on. So how much will she be able to invest in the CD and so on and so forth? Let's just go through the process and solve it. The reason it's called the mixture problem because these two amounts mix up to be the constant amount that we have, in this case, 50,000. Sometimes we use Y and we say X plus Y is 50,000. Sometimes we say, no, we don't want to go with two variables because we haven't covered the system yet. Of course, we have in previous courses. So you could say Y and go with the system of equations, but without the system, this must be 50,000 minus X. Again, Y is that these two amounts must add up to 50,000. Sometimes students make a mistake of writing X minus 50,000. All you have to do, add these two, and you see X and minus X cancel each other, and we get 50,000. So make sure you put this right. Then what comes next is the next column. How much are we going to make here? We're going to make P the principal, the amount of money we have X, times R, which is 0.15 times T. And this is annually, okay? So it refers to 1 year, okay? Therefore, the T is 1. So it's the product of these two times 1. So 0.15 times X. How much do we make here? The product of these two times 1. So 0.07 times 50,000 minus X. Last column, again, must be consistent. When you add these two, must give us 6,000. So we add them up. So this is the equation they're asking for. And now, how do we solve it? Very simple. You can distribute this, or you can multiply both sides by 100. If you multiply by 100, this becomes 15, this becomes 7, and this you add 2 zeros. And then you distribute. It is up to you, it makes no difference. But if you want to distribute just the way it is, what is the product of these two? I hope you see that 7 and 5, their product is 35. We have 2 decimals. We have 4 zeros. So 4 minus 2 gives us 2 zeros. So 5 times 7 is 35, and it gives us 2 zeros. This is 0.15x, and this minus 0.07x. The right side doesn't change. So you can do it without multiplication, without getting rid of decimals. But if you were to get rid of the decimals, the proper way would be to multiply this by 100. And if you did that, it would give you 15x plus 7 times 50,000 minus x. And the right side, 6,000. Now I'm going to add 2 zeros, okay? Because I'm multiplying by 100, which means 600,000, okay? That's the meaning. Anyways, let's combine these two. 0.15 minus 0.07 gives us 0.08x. Subtract 3,500 from 6,000 gives us 2,500. Divide by 0.08 and it gives us $31,250. So the amount to invest at 15% is $31,250. How much do we spend at 7%? 50,000 minus this number. 50,000, take away this number. $18,750. So I hope everybody's clear. It's really not too bad. It's very straightforward. Let's do one more word problem. Could somebody be kind enough to read this one for us, please?
Flora starts riding her bike at 20 miles an hour. After a while, she slows down to 12 miles per hour and maintains that speed for the rest of the trip. The whole trip of 70 miles takes her 4.5 hours. For what distance did she travel at 20 miles per hour?
Perfect. Thank you so much. So we are using what's called a motion problem here. Okay, let me see. Let me write it here somewhere. So motion problem. In the case of a motion problem, D equals RT. D is distance. R is the average speed rate. T is time. Motion problem. Let's set up a table. What type of table? In this case, you have to set up a table such that it has D equals RT, R times T equals D. So, starting, what happens? 20 miles per hour. That's our starting. So we plug it. We are starting at 20 miles per hour. And in the case of word problems, we should always have the units. After a while, she slows down to 12 miles per hour. So we change the speed, the rate. And we keep it up for the rest of the trip. The whole trip of 70 miles. See, we are going one by one. So where does this go? Total distance. 70 miles, total distance. Takes her how long? 4.5 hours. Here's the time. So here's the total time of 4.5 hours. So this is the given. For what distance did she travel at 20 miles per hour? We can answer everything and then answer that one. So what is the time it's going to take us here? Who knows? X, Y, Z, T. But if you call this T, then this one, if the total is 4.5, this must be 4.5 minus T. If this is T or X or Y, whatever variable you choose, or the variable they tell you to choose, then this would be 4.5 minus that. If you go with two variables, let's say X and Y, they add up to 4.5 if you want to go with the system. All right, now we're going to stick with this formula, D equals RT. By the way, when we know that D equals RT, that means we should know T equals D over R. That means we should know R is D over T. And so if this is the case, what distance do we cover here? 20 times T. What about here? 12 times 4.5 minus T. And if the total distance is 70 miles, add this to it, should give us 70 miles. And this is the hardest part, figuring out this formula. The rest is a piece of cake. All you have to do, just distribute 12. 12 times 4 is 48. Half of that is 6. They add up to 54. This is minus 12t. (20t) and minus 12t. 8t. Subtract 54. We get 16. Divide by 2. Divide by 8, we get T equals 2 hours. So that means this was 2, and if this is 2, that means this must be 2.5 hours. Always write the units. So we can figure out the distance then, because it's asking for what distance did she travel at 20 miles per hour. 20 times 2. 40 miles. And (12 times 2.5 gives you 30 miles, and they add up to 70 miles. You can check that. So you can answer all kinds of questions. Let's finish this page by looking at this question. Could somebody be kind enough to read this one for us, please? Anyone?
I'll do it. First, solve the formula for W P equals 2L plus 2W. Then use your result to find the width W of a rectangle whose length is 15 and whose perimeter is 58.
Excellent, thank you. So here's the idea, everybody. So the perimeter, you add up the sides for a rectangular shape is 2W plus 2L. So we want to first solve for W. So we are going to move the 2L. That means we are going to subtract it. And then we have to divide by 2. We'll divide both sides by 2. This is what we get. Now, before we move on, it's very important to know we can't cancel these two. Okay, and that sometimes happens by the students. What you can do, and you don't have to, this is also equal to 2 fractions, p over 2 minus 2L over 2, or L. So you could write it in this fashion. And now we are going to replace the length with 15 and the perimeter with 58. P is 58. L is 15. And so 2 times 15 makes it 30. 58 minus 30 is 28. So the width is 28 divided by 2. And therefore, we get the width equals 14 if the units are given. We answer back with proper units. If not, this is it.